Welcome back to the channel. My name is Tronage, and today we're going to be talking about how this channel is getting an upgrade thanks to something I purchased from rcbenchmark.com. Stick around. This is like total deja vu. What do I mean by that? Well, I feel like I've done this before, and in reality I have. What am I talking about? Well, let me first give you the punchline, and then I'll tell you the little brief history why this feels like deja vu. The punchline is, I got inspired that I had all these props of all different pitches and different sizes and whatnot from the drone drop and the quad box and whatnot. And I have a lot of props, and I figured, they're all a little bit different styles, different brands, different pitches, different sizes. It'd be great to know which one is really best for my needs of any particular quad. So essentially I wanted to test prop and motor combinations, which motors and which props either produce the most thrust, or which props and which motors are the most efficient. Those are really the two things I was looking at, because which one will make me the fastest and which one will make my battery last the longest. In order to test that, you need to use what's called a thrust stand. Thrust stands range in complexity, and they can be cheap or expensive, but the cheapest method is to do a little do-it-yourself, a DIY contraption, where you use kind of like a piece of wood, kind of like in a right angle, and you put a motor up here, and you put this end on like a food scale, and you have an amp meter, and you use the motor with your remote control or with Betaflight, and as the motor pushes this way, it'll make this part go down, and you can measure the thrust pushing down on your food scale, and you can read how much thrust it pushes in grams, and you read how many amps on a little amp meter, and off you go. That's great, but I didn't feel like building anything. I wanted something a little bit more off the shelf and a little bit more easy to manage in a smaller form factor. So this way for you guys, it would be repeatable, and I could pull it out and do further testing for as new props or new motors became into my possession. So I purchased, here it comes where it's deja vu now, I purchased the Tronage thrust stand. This is their version 2 of the thrust stand. The version 1 had the thing coming out the side. This version 2 has the thing coming out the front. And I unboxed, I filmed an unboxing video, and I filmed a how to build it video, and I filmed all kinds of stuff that I was getting ready to, put out as a big just like this video. And I started using it as part of that video. And I ran into a couple of problems. Now, there's nothing so much wrong with the thrust stand, it just didn't do what I thought it would do, or at least the way I wanted it to work. What I wanted is I wanted something that would give me precise, repeatable profiles out of what a motor and a prop combination together, how they perform. What's their efficiency? What's their thrust? Not a full max throttle even, but maybe, some motors may have a little more top end, some may be more linear, and just basically to get an idea of how each motor and prop reacted with each other. Now the Tronage stand sort of does that, but the biggest problem I had with it was you're using a little dial just to control your speed. And that really didn't work out for me, because how do you know when you're at 100%? How do you know when you're at 50%? How do you know when you're at 75? You really don't know. It's just a little dial. There's no notches, there's no nothing. The other problem I had with this was you're literally, if you're using it, you're like 2 feet from this prop spinning at an awful fast rate, and it's terrifying. The sound that it makes, what a quad sounds like when you go, listen, imagine a quad doing a punch out from nothing to full throttle 2 feet from your face. Now, I don't recommend someone going and standing 2 feet from a quad as someone takes off with a punch out, but that's what this is like. Scary as hell, and I wasn't so thrilled with it. So enter now RC Benchmark. they have a range of products that, you know, range from this one. This is their lowest end model that I purchased, and it's, you know, reasonably priced. And then they kind of go up from there, and it's really just how much data you want to collect and how big of a motor you're putting on it. I mean, if you were flying like fixed wing aircraft, you're probably going to have a really big motor, so you need something a little bit more beefier, and you'd be more concerned about some of the other things that the bigger ones can measure. As far as my purpose was concerned, really just cared about thrust and efficiencies. This is really all I cared about. So I went with their lower end model. What's also great about this is because it hooks up to your computer and it runs software to operate it instead of this guy with the little dial. Number one, you know precisely where you're at. If you're at 10% thrust, if you're at 100% thrust, because you're defining where you're at with that. Now, I tried to do something similar with that. I actually hooked up a little flight controller to this to operate the ESCs instead of using the dial on here, and using Betaflight as, you know, with the little sliders to adjust the motor and stuff. And that kind of worked okay, but it still didn't suffice, is that the thing's still spinning in front of me, and there's really no way to log that data other than me looking at it. And the numbers go pretty quick. So you're trying to see, like, you're taking your best guess at what number you last saw and calling that how much thrust it did or whatever. And I didn't feel like that was very repeatable nor scientific, because after I would test a motor, I would test it again and I would test it again, and I would get 3 different numbers. So in my mind, I thought, well, I'll just average those 3 numbers together and that'll be what the result is. But that's not really accurate. That's just averaging a bunch of stuff together. I thought I'd rather something that's more repeatable and will give consistent results and will record exactly what's going on and make it a little bit more streamlined. The RC benchmark product being attached to a computer, you can send a script. So you can say, I want to run it at this percentage and then let it cool off. And then I want to run it to 25% and then drop down and let it cool off. And then I run it to 50% and then let it cool off. And whatever you want to do, you can make up scripts. You know, I don't know if there's even predefined scripts, but you can essentially set up how you want it to test the motor. And while it's doing this script, it's logging all the data that it's collecting, the thrust, the amps, the watts, the volts, everything's all being collected. So you can build a profile for a motor, and, you know, as long as it takes you to run that script, and boom, now you have a full Excel spreadsheet set up to graph or put into a database or whatever you want to do with it. The other thing that's wonderful about that is 2 things. One, it's attached to a computer, so you can put this as far away from you as possible, as long as you have a USB cable long enough to do that. And if you want to get really technical, USB cables can only be a certain length, but then you can put, you know, things that turn USB into, you know, network cable and then back to USB, so you can make it like hundreds of feet away if you wanted to be for whatever reason. You can be far away from it. And since it's running a script, you could almost hit go and run and hide and not even be near this thing going off. So that's what I really liked about this, that it's scripted, it collects the data, it's running on USB, so I don't have to be near the thing while it's running, and it can just do its thing. So I know that's a whole lot of talking, but I figured I wanted to let you know what was going on and what we're doing. So here's what we're going to do. You guys are going to come in close, and we're going to unbox this bad boy together. We'll look at the quality of the components. We'll see, because I'm going to probably have to buy some parts for it. Why was that? Because the Tronage thrust stand has a base to it. You can have something to hold on to, and you can, you know, operate it. This is more designed to be bolted to something, or at the very least bolted to a base of some sort. So I'm going to need to see what kind of hardware I may need, if I need to get like a piece of wood or something. So I may have to make a run to the store and get it, but we'll figure that out together. And I'll let you know what I needed to buy for it and how I set mine up. All right. So why don't you come in close first? Let's crack this box open and see what's inside. All right, so let's crack this guy open and see what we got inside. I got my razor blade, and we're gonna cut all this tape and packaging stuff here. And then we have some packing material stuff, which is not exciting. Put that to the side. And then, ooh, I think we're gonna have boxception. We do. Nothing else in that box, just some more packing material. So we have a box within a box, boxception. And this is a very heavy box, pretty plain white box with some labeling on it, but that's fine and good because I'd rather them spend the money on the product than the packaging, although sometimes packaging stuff is pretty cool. We'll break our seal on that. And then which way does this open? Does this lift up? Yes, this lifts up. All right. So we open this up, and if there's another box in here, that'll be epic. Oh, nope, I did it wrong. This goes like this, and then this comes up. There we go. All right, we got a little foam action. Oh, this is really packaged nice, actually. So look at this. It's got like each thing got its own like little component, so it's all like safe and secure when you get it. That's actually really nice. I'd rather that, you know, this is nice because you know you're going to be getting it from the factory in one piece. So here we go. We got an instruction manual of how to use it and all that fun goodness. So we'll go through that later on. And then we just got all these parts. So let's just start pulling these parts out here. We got this thing. I don't know what this is. Maybe some sort of circuit board, it feels like. And we got this thing here. We got some bolts. And look at that. They even give you the Allen keys and the tools you're going to need. That's freaking awesome. And we got some wiring harness type stuff to hook things up with. Great. Anything else in there? No. Let's go in this next compartment here. What do we got here? Okay, this is the mount that the motor is going to be attached to, which is pretty nice, thick, durable. Looks nice. What do we got in here? Oh, they even gave you the USB cord to hook it up to your computer, so you don't need to go and find yourself one of those. Anything else? What about in here? Oh, something in here. Okay, this is the, I believe, the load cell, I think, that we'll be using to measure the thrust with. Let's see what's in here. Ooh, another motor mount, I think, for smaller motors, perhaps. I think that's what that is. It's in here. It's like a little present in each little pocket. Okay, and this is the main base of it, looks like. Okay, and is that it? I think that's it. Yep, I took something out of every compartment, and that's it. So that's actually really nice how they have this foam with all the pieces individually in there, so you don't have to worry about them getting damaged or whatnot. Although it does mean that there will be some assembly required. So let's take a recap here. We got our base, we got our little plates here for our motors, our load cell, I think that's called, USB cable, tools and screws, the actual PCB board that's going to be doing all the magic, and some wiring stuff. All right, so what we're going to do next, I'm going to take kind of this thing out. I'm going to open up this instructions and we'll go through the building of this and see what we end up with. All right, so I've kind of gone through and I think I've gathered all the parts that I need to actually put this together. So over here, this section, this is what comes with the package. And over here is stuff that I needed to obtain. So the 4 screws and the block of wood, I just happen to have laying around as scrap wood in my house, as well as the screws I just happen to have laying around. So those I didn't have to purchase, but really what we're looking for is any either big bolt or a couple of screws. I'm using 4 screws. I didn't want to put one in this last hole because if you know anything about woodworking, if you put a screw very close to the edge of the wood, it can possibly split. And I figured 2 screws on each side, so 4 screws total, I think is enough to secure this. I don't see that being able to rip out anytime too soon. So I think that's going to be sufficient to hold it. And also when you're choosing what screw to use, if you're going to be using it on a surface, just make sure the length of your screw is equivalent to the thickness, unless you don't mind a screw sticking out. But you want to make sure you get a nice good bite in it, including the thickness of the piece. And this just happened to work out quite nicely with what I already had on hand. The other thing you need to get is you do need to get yourself a nice big old ESC. Now, you probably can run this with the ESCs that we're used to using. However, motors in a static thrust test, which is what this is eventually going to be, is a static thrust test, they will have a slightly higher amp draw than when they're on your quad. So you want to make sure that your ESC has enough power to not burn itself out, essentially. So typically with what I'm looking at, from the motors and the propellers I'm looking at I'm going to be drawing roughly about 30 amps or so. So basically the rule of thumb is you always want to have an ESC that's about double that for testing, so that you make sure you have tons of overhead, so that if it goes into the 40s and the 50s or whatever, your ESC will handle it. So I just got a big old chunky ESC because, again, I'm not really so much concerned about testing the ESC's ability. I'm really just looking at motor and prop combinations, with the ESC just delivering whatever is, you know, all things being equal. The idea being that this will become a sterile environment, that everything I test will always be on this ESC. So therefore all of my results will be comparable to each other because they're all using this exact same ESC. So you do need an ESC to hook up, and that's really it. So let's start building. So in the interest of time, I already pre-drilled some pilot holes. All I did was I took the base plate, put it on here where I wanted it, took a pencil, drew a couple little circles, and drilled a couple pilot holes in. So now we're going to secure this down because this will give us a nice base to work on. And what technique you want to do is, you don't want to tighten them all down like one at a time all the way. You want to tighten them almost all the way and then go back and tighten them the rest of the way. Just this way, so that everything kind of seats itself down nice and secure. All right, so let's look at our instructions here. And first step is to attach our load cell, attach our board, and some spacers and some screws. All right, so let's open this guy up. Get our first look at our board. Very well packaged with this foam so that you make sure that all the pins don't get dented or bent. Enough looking. Let's get this put together. So we need that. Now we need some hardware. Oh, that's nice. So I was looking through the hardware here. There's also some washers here, and it says optional washers to aid with the installation of motors on the testing device. So basically they just gave you some washers because I can imagine with some screws it may be difficult, they may slip around on this. They gave you some washers to help your installation. So that's really a nice little touch. All right, so we're going to take these long bolts here and we're going to put them through these two washers first. Then they're going to pass through our board like that. Then they're going to pass through the spacers. And then our load cell, it says that we want to have it with the wires up, and it's showing them on the right side here. And on the bottom, I'm noticing there's a little arrow pointing out, so it looks like it's going to go right like this. Put these through here. And like that. And what's nice is this is all tapped already, so there's no bolts to worry about, which is great. Okay, looking good. All right, our next step is we're going to put our motor mounting part on. So there's two options here that we need to worry about. And obviously, this one's quite large. I mean, for the size motors that we're going to be using, this would be kind of silly. So I'm going to be going with this one. I feel like this is a lot more appropriate to the size motor that we're going to be using. And this just bolts on the front with these other bolts. And I have to say, this hardware is like really well done. It feels like it's, even though it looks like metal, it looks like it's been powder coated silver or something, or they just did a really good job of refining all the edges. There's no sharp edges on any of this. It just has a really nice, clean, finished feel to it. And this is like really simple to put together. And now we attach the connector to our load cell. And it says orientation is not important. So I guess that means it doesn't matter which goes to which, but doesn't even have any indication of any of them being anything. So I'm just going to put it on this way. Whatever looks best. So this way I think looks best. Oh wow, It's a very long piece of wire that they give you. All right, so the next thing we have is this wire that we have to put a connector on, because one end obviously will just screw into the board over here, onto these screw attachments. But the other end, I want to attach a XT60 connector so I can just put this right onto a LiPo pack. So I'm going to go just attach a XT60 connector to one of these, and I'll be right back. I got my little XT60 connector on one end of this wire. And let's connect this up. Now, before we do that, I actually made a little other alteration, which I want to talk about. So my ESC that I bought came with an XT60 connector. Now, I could very easily have taken my cutter, cut these wires, and attached my ESC directly. But I wanted to leave this connector on here, and I'll explain why in a minute. But to make my little extension, which is in my hand here, what I did was I just took a little piece of wire that came off of here and put another XT60 connector on there. So I had a way to connect to this and then have the wires that I'm going to attach to the board here. So now these are the 4 wires that are going to attach to the board. Now, why did I want to leave this connector in place? The reason is because this board for the thrust stand has a limit of, I think it's 40 amps. In order to bypass that, I want to also have the ability, I may not get the amps reading, I can use an external amp meter that I have instead of having it collect the amps. But then if I unplug it from the board, I can bypass the board entirely, because it's all the reason why you're running your power into the board and then from the board into the ESC is that you're basically, that's using to measure how many amps it's drawing. If I hook up the battery directly to the ESC, then it's bypassing that part of the board and I don't have to worry about any problems or any issues with the 40 amps going through the board. So in the instructions, you're supposed to do the power connections first, and they go in from the back. And I think they do this so that you don't confuse anything. And positive is going to go on the top. And it's going to go into this one, the bottom one, I believe, which is correct. It says ground. Let me clip that off. There we go. It looks nice and professional already. Okay. Now for our ESC wire, they're going to go in through this front here. So if I tip this up, you can see this top one is positive. And actually, I'll just undo both so I can plug them both in at the same time. Negative on the bottom, positive on the top. And now we're ready to hook up our ESC to the whole mix. Now, again, I did a little bit of a change here, but the idea is basically we need some way to connect this to this, and you could go through and solder bullet connectors on here or cut these bullet connectors off and then solder the wires on. But if I want to swap out motors really quick, that seemed like a lot of a process to do. So this was actually an item that I bought on Amazon. I'll put a link in the description below. But this is basically what's known as a 3-way terminal. It lets me put wires on this side, and all this really is a bar of metal that goes across, bar of metal that goes across, and bar of metal that goes across, so that I can attach wires on this side. And these I have the bullet connectors on, so I will attach those to the bullet connectors here, like so. You know, they just plug right in. And then on this side is where I'm going to actually put my motor so that it connects up. So this way I have a way to, if I want to switch out a motor, I just loosen these 3 screws, pull out the motor, put my other motor on, tighten those screws down. So these 2 wires here, I'm guessing these are the motor probes. I guess they give you 2 ones extra maybe? I don't know. I'm going to go with, I don't know. Well, let's do yellow. So I'll plug that onto here as such. My ESC signal wire is also going to go on these top set of pins, and this orientation does matter. It's negative on this end, positive in the middle, and then signal on the right. And now the ESC will live right here, anchored to this unit. It has a little spot to actually zip tie it so everything stays nice and neat. And the little motor probe looks like you just attach it to one of the signal wires. I'm actually going to mount my ESC here. All right, we're going to go something like that, I think looks good. All right, like that. Looks like a good spot. Trim my little zip tie off. All right, now I'm going to take my little probe, and what I'm going to do is I'm just going to stick it into this first phase here, like so. And then I'm going to plug the first phase of my little block here into it, so that it kind of gets jammed in there with everything else. There. So now I have that probe in. So now I have my 3 phases for my motor ready to go, with one of them having the RPM probe. And now the first motor I guess I'm going to test is this racer star, since it seems to be sitting here hanging out. See, that's what you want, just a little bit sticking out, enough to grab, but not enough to go deep into the motor. And this is a nice little handy selection I got of M3 bolts. I'll put a link in the description below of the selection, but it's great because anytime you need any kind of random length M3 bolt, you got it right here. Love that little kit. And if you're curious, the motor that I'm going to do here first is a Racer Star. It's their BR2205 size motor, and these are a 2600 kV, I believe. We got to hook up our motor to our ESC, and that's where this little block comes in. So now we're all set up. All I did there is I just added one more extra zip tie just to kind of bundle in my wires, since I kind of added a few extra wires in here that aren't necessarily supposed to be there. I just did it to make so I can swap out my motors very, very easily. But I think this looks really, really cool now. I love that they included the Allen keys though. That's really nice touch. And they're like nice ones. They're not just those little junky pot metal ones. They seem pretty robust. Since my terminal block is done, I'll put my little cover on it so I don't end up with any kind of things touching it or shorting it. All right, let's get our USB cord on here. Oh, and this is making me really happy. Nice long USB cable. I don't know how long, I'm gonna estimate it's about 6 feet long, which is good because I don't want to be on top of this thing. I had enough of that with my old thrust stand. Now we just gotta hook it up to a computer, put a battery on here, put a prop on here, and we can do some testing. I'm not gonna put any props on it just yet because I'm gonna wait till I'm ready to test everything. So I'm gonna do it under a little more safety condition, but I'm just gonna run the test with no prop on there just to see how things work. All right, so now that we got it built, now let's take a look at the software end of things. Now, it was really easy to download the software. The instructions were in the manual. You basically go to a website, you click a link, you download, you run it, it installs, you're done. It's really simple and easy to set up. So you fire up the software, and here we are. You get this safety agreement here, basically just, follow proper safety protocols, and you click accept. And here you go, you're greeted with your initial screen here. Now, a couple of things I've gone through on the setup tab is I changed the thrust to be gram force, because that's what I'm just used to. Normal data sheets for our hobby listed in grams. So I just changed it from grams, it was on kilogram. And the RPM sensor for this motor. So right now I'm testing the Racer Star 2205, I believe. Yeah, Racer Star 2205s. They're 2600 kV motor, and I know that it has 14 poles in it. I know this because I know it has 14 magnets in it. And if you click over here, if you're not sure, you click over here on this little question mark, and it shows you this little description here, and it basically tells you the easiest way to find out how many poles a motor has is you take off the bell, you count the number of magnets in there, and that'll tell you how many poles it has. So, and I know that this motor has 14 magnets, so therefore it has 14 poles. So I've changed this to 14. It was set at 12 default. I also clicked over here the activate experimental scripting mode, and we'll get into that in a few minutes when we get down to over here where it says automatic control. All right, so we have our setup kind of set up, but we don't have anything set up. Nothing's plugged in. Got to plug it in. So just as if like with Betaflight, you have your USB cable and your quad, and it doesn't show a port, and when you plug it in, it comes to life. Same thing here. You plug in your USB cable, you get the little, it detected something, and now it's showing COM4 where the thrust stand is connected. So let's hit connect. It's going to connect to the thrust stand, and here we are. We're now connected to the thrust stand. It's showing what series it is. It's the 1520, the firmware it's running. It's showing that it's getting all this information going on right now. And like, for example, this thrust thing here live, if I push on it with my hand, you'll see it does actually measure how many grams of thrust are being produced by the props on there, which is pretty cool. So now if you go down here to utilities, you can actually set your minimum and maximum of your ESCs, because the ESCs, you know, we're kind of used to it just being like 1,000 at bottom stick and 2,000 at top stick, and everything in between is sort of like the range of motion. But for the purposes of this thrust stand, there's no remote control, there's no flight controller, there's no anything. So essentially you just got to figure out where your minimum and maximum is for the motor so that you know what values to send to the ESC so that you can spin up the motor essentially. And I found that this motor spun up around 115, and it kind of topped out at around 1200-ish or so, like that. So I just made my values around there so I could narrow down the spectrum of what the motor activates on, if you will. Safety cutoffs, this is basically different safety measures that you can put into this so that if one of these gets violated, it'll shut everything down so you don't have to worry about things going wrong. I mean, you do have to worry about things going wrong, but it's a safety precaution, if you will. So for example, if you're running a 30 amp ESC on here, then you probably don't want to be running your continuous current at 40 because that'll clearly burn it out. So it won't let it go above that. If it gets to 30 amps continuously or a peak at 50, I'm running a 60 amp ESC right now. So a continuous current of 40 and a burst current of 50 is well within the limits of this ESC. So you would need to, if you're using a different ESC or different materials, you need to just check the manufacturer's information to make sure you put this correctly. And I will put a word of warning here that manufacturers can lie on their spec sheets. So just because something says it has a continuous current of 30 amps doesn't mean it really has a continuous current working of 30 amps. So just be cautious when you're using these things because you could burn up ESCs even though they were within what you thought were manufacturer specs. But that's what this screen is for. And then you have manual control. Now manual control, now I will say, as you saw before when we built it, the motor's on here. There is no prop. I'm not running any props right now on it. It is just a motor. So you'll hear the motor spinning up, but there's no prop, so I'm not worried or bothered by it spinning up in front of me. So what you would do if you wanted to do manual mode, you just have your little ESC here. And remember I set my minimum value to 1,115. Well, that's where it's showing bottom of it being. And if I was to slide it all the way to the top, it's at 1240, which is exactly what I set as my maximum value. So that's sort of the range that the motor was operating within the ESC. Very similar to in Betaflight, again, when you're in the motors tab and you have to tick off that box to actually say, I agreed to, you know, spinning up my motors and I don't want to accidentally do this. It's the same thing here. You just, this little tick box, you have to click that first. When you do that, it'll arm. Now, if you don't have your battery attached like I don't, nothing really happens. So I will now attach my battery to the unit. Now, still nothing happened because nothing is armed. Now, if I click this tick box, you'll hear the ESC tone up. And now it's armed, but we're still below the threshold of it working. What's also neat is while we're here, I'll throw on, you can turn on the RPMs, And I'll turn on the ESC power charts here so we can see what's going on. And I'll just bring this up. And you can see it just starts spinning up the motor, and I can go more. See, now you can see I went a little too far and it's starting to get a little messy. So around, as I said, around 1200 or so is where it's all nice and happy. That would be around the max. And then we'll disarm. All right, and that's really how the manual control section works. It's really all it does. Now in automatic control, I'm gonna unplug this again so it doesn't keep beeping at me. It'll keep beeping a little bit, but in the scripting mode, the key thing you have to remember is you don't really need to know how to do any kind of scripting languages, because they do have some really nice predefined scripts ready for you to go, and you can just go in and plug in your own values. The way you get to those is you could either type a script right here. If you knew JavaScript and you want to just started putting in a script of something to go, by all means, knock yourself out. I have no idea how to program in JavaScript, but I do know how to click this little button here that brings a drop-down menu of some different scripts you can run. There's one that you can try to estimate how many poles that a motor may have. You can try to measure the kV of a motor, you know, compare, you know. Again, these are all experimental. So I'm not really using these right now. That's not what I'm looking for. I'm looking for more of these like sweep modes where it'll go through the different speeds of a motor and sample what it's doing at those speeds, or a custom sequence, go to this speed, hold it for a little while, go to this speed, hold it for a little while, kind of a thing, so you can say, okay, I want to take a measurement at this speed, that speed, whatever. Those are the types of things that I'm going to be interested in. And then so what I did was I took this one that was the sweep one, the sweep discrete, where it's going to say go to this speed, go to that speed, and just go do 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 do. Yes, I can sing. It's one of my talents. So I just opened up my little test version of it, and all that I did in here to edit it, let me just show you how I edit it. You can go to sweep discrete, and you click this clone button. When you do this clone button, it makes a version that you can then edit. And when you edit it, I'll go back to my version now. Edit. When you're over here on the edit screen, you can type in whatever you want to do to change your values. And then over here where it says file name, that's where you put your file name of whatever you want to call it. So for mine, I just called it test for now. And I set the minimum value to be where it was the motor didn't spin at all. I set the maximum to be where I felt it was most stable at its maximum RPMs. And then I wanted to do 10 steps in between those. So it's going to do 10 different levels of acceleration, if you will. And I'm going to give it 3 seconds to settle into that speed before it takes a measurement. So it's not just like, you know, like let it settle in, get chill, get comfortable. And then I'm going to make it take 20 samples and then average them all together. So this way, you know, there may be a couple little fluctuations, but it'll take 20 samples, average them all out, and that'll be what it calls that measurement. And then I would like it to go from 0 ramp up and then step itself back down. That's why it says true. If it said false, it would, you know, just go up and then stop. And I'm going to have it repeat it 1 time. So let's see what this script looks like and sounds like. So let's do run, and then you do start. Oh, but I have to plug in a battery. Okay, battery's plugged in. Okay, and we'll hit start. So it waited, it's starting up. Now remember that initial value, there's no motor movement, so it's not going to start going. And now it's up to the next step. And I'm not doing anything. This is just running a script all by itself. And that's it. And that whole time it was doing that, it's actually sampling measurements, and it's actually putting it into a folder. This is the file that was generated from that little test. Now obviously there's no props on there, so there's really no valuable data per se in this file, but it's a good demonstration of what it does. You know, depending on how deep you want to go into the data is how deep we can go, because now we have this ability to gather this data, log this data, and I didn't have to do anything. This Excel file we're looking at right now, I just hit go, and I could walk away and come back, and it would have generated this file that I could then use as data points to create a graph and basically show how this motor works with a prop. So that's why this is incredible. Can you tell I'm excited? Because I'm excited. Let's wrap this up, and let me give you my pros and my cons about this whole setup. So basically the pros: excellent build quality. Metal is amazing. There's no sharp edges. I think it's powder coated. I could be wrong, but if it's not powder coated, they did something to the metal to make it just feel like finished. It doesn't feel like raw bare metal. It's really actually has a very finished feel to it. The circuitry on there, the circuit board and everything is really professional. Like, everything looks very, very professional. It doesn't look, you know, some guy in his backyard, you know, cobbling this together. It looks very professionally done. Putting it together was super easy. The manual is super easy. You don't even have to read the words. You can just look at the pictures and it's obvious what you have to put together. So setup was super easy. Plugging it into the computer was super easy. It basically configured itself, and I ran the software that it came with, and it just worked. I didn't have to do anything crazy or fancy or out of the ordinary. It was just worked. Cons. I'm kind of hard pressed to think of one, to be honest with you, because it ticks off every single box I wanted it to do. I don't know. I don't have a real con. I'm sorry. It does exactly what I want it to do, and there's nothing really I'm sitting here thinking, man, I wish it did this, because it does it all. So I guess the only con, I guess, is that I do wish that it had like maybe a bigger base, so I didn't have to like mount it onto a piece of wood, so then I had a bigger surface to grip onto. But again, that would then affect its cost, because it would be a bigger piece of metal, so shipping would be more because it would weigh more, and then the packaging would probably have to be bigger because there would be a big plate of metal in it. And it's not really a necessity, and it just involved me going and grabbing a piece of scrap wood and a couple scrap screws I had laying around and bolting it down. You know, in the instructions it even shows you can just clamp it directly to something. You don't even need to mount it. You can just clamp it down with 2 C-clamps on the sides where you would put the screws. I just wanted a bigger surface to grip to, so that's why I put on a piece of wood. But I gotta say, I love this thing. This thing is awesome. I highly recommend it. If you want to know what's going on with your stuff, this is definitely the thing to check out. And that's going to be it for part 1. Part 2, I'm actually now going to start creating information, creating data, throwing on all the props that I have, throwing on all the motors that I have, and doing all the combinations thereof, and really finding out what the sweet spot is for certain props and motor combinations, what's the best thruster, what's the best efficiency, and I'll be sharing that with you guys, and that'll be the part 2 of this video. So I just wanted to get this out there for you first, and then let me do some testing. Let me play with this guy already, and I'll get you part 2 with all the data, all right? So, as always, my name is Tronage. Fly strong.